Okay, my name is Benjamin. I will be representing the white team, and we are the cooling station. And on the white team is myself and my partner Austin. We have two ranges. Austin's range is 46 to 52 degrees Celsius, and my range was 58 to 65 degrees Celsius. Today I'm going to be reporting on our steady-state operating curve, the step response, and the FOPDT modeling. For our system, we have a manipulated variable, which is just the input power to the system, and our control variable is the output temperature of the system. Here is an example of the steady-state operation of our system. And to get the steady-state operating curve, we ran the system at varying power inputs, and then we got an output average temperature and an uncertainty. And you'll see here, this is a 120-second run. For our system, you have to run it a couple times because 120 seconds is actually the maximum experiment time. And if you just run it from the system being cold for 120 seconds, it will not reach steady state. So you'll have to run it a couple times. I think this is the third. And as you can see, it starts out at a high temperature, which is where it left off. You know, it shut down for a few seconds and started to heat up, and then it cools off and reaches steady state. For this one, we had an average output temperature of 59 degrees Celsius, and so this was a data point for my operating range. Here are the results for all the runs, all the steady-state operation runs. Here is my range, which is the lower input, and then Austin's the upper input. And you can see at the lower input range, there's a lot less uncertainty than at the upper input range, Austin's range. And Austin's range actually went down to 46 degrees Celsius, but at 100% input, we were only getting an average of 47 degrees Celsius. So here is the steady-state operating curve for the two ranges. This is my range, this is Austin's range. And you can see, if you look at the curve for his range, it starts to bottom out at around 47 degrees Celsius. And so we got a linear curve fit for my range and for Austin's range. The next thing was the step response. We did two different experiment parameters: a step up from 45 to 50%, and so a step in my range, and then a step from 70 to 75% in Austin's range. And for all experiments, we used the FIT2 to get the FOPDT parameters. Here is an example of one of the step response experiments ran. So this is mine from 40 to 45%. And when you're running the cooling station, it fluctuates a whole bunch. And so even if you zoom in here, you can't really see much of a dead time. And this was the case about all the experiments. There's not much. If there is a dead time, it's too small to observe with the inherent invariability of the system. And so here's the results of the step response. For my range, we had a gain of negative 0.37 degrees C per percent, and Austin's we had a negative 0.12 degrees per percent, and a time constant of 18 seconds for my range and 22 seconds for Austin's range. And I'll show this later, but this is the same as the slope for the steady-state operating curve for his range, but this is not the same value that we got for the slope for my steady-state operating curve. And then also did some FOPDT modeling. So this is the model for one of the experiments, and you can see up here the parameters of the model, and it fits fairly well for this drop down. And so just to repeat the results that I went through, we've got two steady-state operating equations. This is the top first one's for 55 to 60, 65 degrees Celsius, and then the second one for 47 to 52. And so if you look here, this is the step response. So the steady-state gain does not match up with the slope of this steady-state operating curve, but for the second range, the steady-state operating curve slope matches up with the steady-state gain. And then here are the parameters for the FOPD model.